this is actually the first lesson, that is the introduction, matter and measurements, what we have. Now, whenever we study, that is nothing but the study of matter, which is there, all the things which are around us, which has mass and occupies space, is called as matter. Okay, so now here when we study chemistry, the most important thing is we start with the very simple physical, physical smallest minute particles, which are, you can say that, matter, as I told you, we have defined it as the physical material of the universe, and it is anything that has mass and occupies space. And this is actually a property which helps us to recognize a particular type of matter and to distinguish one matter from the other. Okay, so we have to actually specify or study the different characteristic properties of different materials, and based on the characteristic properties of different materials, we actually identify them or distinguish them as the different materials what we have. Now, when we start with the matter, the smallest minute particle of matter, can you tell me what is the smallest minute particle of any matter?
Electrons.
Yeah, it is actually, yeah. If you consider, it is the atoms. Okay, so atoms are the smallest minute particles of any matter what we see around us. Now, in these atoms, we have the subatomic particles, like we have the protons, then we have the neutrons, and we have the electrons. Okay, can you tell me some small information about this subatomic particles of atoms, that is protons, neutrons, and electrons?
Protons are positively charged.
Yeah, where are they actually situated in an atom?
They're in the nucleus of the atom.
Yes, exactly. Positively charged particles which are present in the nucleus of the atom. And what is the nucleus of an atom? Can you tell me?
It's the center of the atom.
Yeah, it's the center of the atom where the whole of the mass is said to be concentrated. The entire mass of a particular atom is said to be concentrated in the nucleus, and that is the most important part of an atom. Then comes the neutrons. Can you tell me something about neutrons?
Neutrons have a neutral charge and they balance out the atom, and they're also in the nucleus.
Yeah, neutrons, as the name suggests, they are totally neutral. They do not have any type of charge, and they are also present in the nucleus along with the protons. Okay, then comes the most important part, is the electrons. Can you tell me something about electrons?
They have a negative charge and they circulate the atom in certain rings, and each shell has 8 electrons.
Yes, exactly. So electrons are the most important particles of atoms. They are actually not present in the nucleus. They are surrounding the nucleus in different shells, and they are negatively charged particles. They are always revolving around the nucleus. So this is basically the very small information about the atoms. Now we know that each matter, whatever we consider, it is made up of many millions of minute particles, which are atoms, you can say. And these are the small building blocks of matter. Atoms are said to be the small building blocks of matter. Now, when we actually consider about the elements, okay, now after the atoms, we have the most important part is the elements. Can you tell me, in chemistry, when we start studying about chemistry, the first thing what we, after atoms, what we come to know is the elements. Can you tell me what is an element?
An element is like several atoms put together to form like a substance.
Yes. So element is the simplest substance which is made up of a similar type of atoms. So consider any element, like if you take the element oxygen, O2. Okay, now all of these atoms of oxygen are similar to each other, exactly identical to each other, and these atoms together, they form the element. These are the substances which are made up of similar building blocks, which are the similar atoms, okay, elements. And we see that we till now, till date, can you tell me how many elements are present totally?
I think, is it 256? I don't remember the actual.
It is around 118 elements till date. We actually know. Okay. So around 118 elements are known to us till date. And actually, when we have the elements, we have actually dividing these elements into three types. One is the metals. Most part of the elements is in the portion of metals. Then we have the non-metals. And we have the metalloids. The periodic table, if you go to see, the periodic table actually gives us the placement of all of these elements till now, whatever till date we know, all of these elements have been given a specific position in the periodic table. All are placed according to, can you tell me how is the placement of elements in the periodic table?
It's arranged based on the atomic number, well, increasing atomic mass and increasing atomic number.
Yeah, it is placed in the order of increasing atomic number. So from first hydrogen, where the atomic number is 1, we start with increasing atomic number, and in relation with the increasing atomic number, these elements are placed in the periodic table. Now, why are they placed in the periodic table? So as to study them in a proper way. Okay, so now you can see that the properties of matter, what we actually study, relate to both the kinds of atoms the matter contains and the arrangement of these atoms. So it's not important that what kind of atoms they are actually present here, what is the composition, along with the composition, how is the structure, how is the arrangement of these atoms in a particular matter, that is also very important, and that gives a particular matter its characteristic properties, that is based on the different kinds of atom, what is the composition of the atoms which are present, and what is the arrangement of atoms in a particular substance, that gives its characteristic properties. Now, can you tell me, we have come across elements, we have come across atoms. Can you tell me what do you mean by molecules?
Molecules are atoms put together, and it could be different atoms.
Yes, exactly. So basically here in a molecule, we have 2 or more atoms joined together in specific excuse me, specific shapes. Okay, so a molecule, like if you take a molecule of oxygen, you know that oxygen is never written as O, it is written as O2. Why is it written as O2? Because it is diatomic element. We say it is a diatomic element. Diatomic element means in free state in nature, whenever we go to see the presence of oxygen, it is present with 2 atoms of oxygen always fused together. There is a double bond between 2 oxygen atoms, and that is the reason why we always write it as O2, because it is O double bond O. 2 atoms are linked together with a double bond, and that is how a molecule of oxygen is going to be present in nature in the free state. Now, so also it's not that we always have the atoms of the same type which are bonded together. We do have, for the different compounds, the atoms of different elements are also bounded. Like if you take the example of water, H2O. So it is here 1 molecule of H2O. When we consider the 1 molecule of water, which is H2O, that is going to have 2 atoms of hydrogen and plus 1 atom of oxygen bonded together, and this is going to form 1 molecule of water. Okay, so here when we talk about the molecules, it is 2 or more atoms which may be of different kind, which are joined together in specific shapes, that gives us a molecule of a compound. Okay, so that is the difference between an atom and the molecule. Atom is a part which is all similar. Like if you consider the atoms of a single element like oxygen, all the atoms are going to be identical. Molecules, as we take, it is the combination of two or more atoms, which may be of different elements also. As we have seen in water, it is two atoms of hydrogen with one atom of oxygen, which are bonded together with different bonds, and that makes up one molecule of water, which is H2O. Okay, so this is how we have the simpler things like atoms, elements, and molecules of this, because when we start studying chemistry, we should know the basic things. Now, we can see the figures here, which give us the molecules of different compounds. You can see, now I'll just show you the figures of different compounds. Here in the figure, they have given us just a minute. Yeah, so here we can see the different molecules shown here in the figure. So here we can see the different molecules which are seen. Here you can see, as I've told you, the oxygen molecule made up of two oxygen atoms. They are bonded like this. You have the molecule of water, which is one atom of oxygen with two atoms of hydrogen. Carbon dioxide, CO2. You can see this is H2O, this is O2, this is CO2. This is ethanol, then ethyl glycol. So these are, now here the white color spheres are shown of hydrogen, the red color are oxygen, and the black color are carbon. So we have the different compounds like ethanol, ethylene glycol, and aspirin. Now you can see here, the white, black, and red spheres represent atoms of hydrogen, carbon, and oxygen respectively. If you go to see how many carbon atoms are present in one aspirin molecule. So this is perfectly one aspirin molecule. So Ria, can you tell me what is the number of carbon atoms present in this one molecule of aspirin?
Is it 13 that I can see only 13?
It is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Are they 9?
Oh, yeah, yeah. I was
9. Yeah, the black color spheres you can see, those are carbon. The red colors ones are oxygen, and the white color spheres what we see are hydrogen. So looking at this molecule, you can just count 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 atoms of carbon. This is a single molecule of aspirin. All of these are single molecules of different compounds, like ethanol also we have here. Then we have ethylene glycol is also there. Carbon dioxide, CO2, water, oxygen, and all of this. So here you can even count the number of hydrogen, 1, 2, 3, 4, 5, 6, 7. Okay, 7 atoms of hydrogen. Then can you tell me oxygen, 1, 2, 3, 4? There are 4 atoms of oxygen. So you have many different compounds from which are made of different atoms of different elements combined together to form a compound. Once the compound is formed, the total identity of the element is totally lost. Now, if you take this particular compound, which is aspirin, made up of so many atoms of hydrogen, carbon, and oxygen. Now, once this molecule of aspirin is formed, you can see that the identity of carbon, hydrogen, and oxygen is totally lost. It has a totally new identity of itself once the compound is formed. So that is the thing of a compound. So can you tell me, Ria, what do you mean by a compound?
A compound is different molecules put together.
Yeah. So when atoms of different elements in a specific proper proportion, when they come together, when they are bonded together in a fixed proportion, very important. It is not that any number of atoms coming together will form a compound. You have to have the fixed proportion, like in water, as you know that the proportion of hydrogen to oxygen is 2:1. So two atoms have to fuse with one atom of oxygen, then and then only we have the molecule of water. So also for carbon dioxide, we have C:O. The ratio is going to be 1:2. One atom of carbon with two atoms of oxygen. So this particular proportion of the number of atoms of every element which is present is going to be fixed. And then when these atoms of different elements are coming in fixed proportions together, we have a compound form. Now, once the compound is formed, the identity of each of the element is totally lost, and the compound as a whole, it is going to be having a very important, a totally new chemical composition, and its identity is going to be changed. Okay, the identity doesn't remain the same. The properties of the elements are not going to retain. The new properties are acquired by this particular element. It depends on how these atoms are bonded to each other, and all of those things. What is the number of atoms of each element? Based on this particular compound which is formed has its own characteristic properties. It has its own new identity. Because see, whenever we have the chemical compound form, it is the chemical change which is taking place. It's not a physical change. So the total identity of the initial elements is going to change, and it is going to acquire a total new identity when a compound is going to be formed. Okay, so this is we can see the shapes of the compounds. Also, you can see when you take a hydrogen and if you take water and carbon dioxide, you can see the change in the shape. One is the water molecule is in the form of a bend shape. Okay, so we can see the bend shape between the hydrogen and oxygen, and carbon dioxide, if you see, it is having a straight linear shape. Okay, so even though the number of atoms are 3 in both of these compounds, the shape of the molecule is not the same. And because of the shapes, the bonds which are present, because of the atoms which are present, they acquire different shapes. We are going to study in detail about the shapes and all of those things. But it is not that if 3 atoms of different elements come together, they have a specific similar shape. You can see the difference in the shape of carbon dioxide and water here. One is in the bend shape and one is a straight, you can see a straight line linear shape of carbon dioxide, wherein oxygen atom is in between and carbon atoms are surrounding on two parts. On the two different parts, you can see oxygen is attached to carbon atoms. So this is how the molecules of different compounds have the shapes, and based on the shapes, we have the different characteristics, properties of those particular things.